Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 79 of 100 days to CAT Quant series. In this video, we will be discussing 5 questions from quantitative aptitude. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. If you want to attempt these 5 questions in the form of a test, you can sign up in our portal, the gurukul.org.in. The link is provided in the description below. So once you sign up or once you enroll, you'll get access to a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRDI, and VRs. We'll be uploading 100 tests in each section. So if you're a serious CAT 25 aspirant, you cannot afford missing these tests. And these tests are absolutely for free. And without any further delay, let's get started with the first question. Now coming to the first question, two alloys of aluminium have different percentage of aluminium in them. The first one weighs 8 kg and the second one weighs 16 kg. One piece of the same weight is cut from each of the alloys. The first piece is alloyed with the second alloy and the second piece is alloyed with the first alloy. As a result, the percentages of aluminium become same in the resulting two new alloys. What is the weight of each cut off piece? So initially there are two pieces of aluminium having a 8 kgs weight and 16 kgs weight. Now let me consider the percentage of aluminium in this 8 kgs piece be A% and in this 16 kgs piece would be B%. Now one piece of same weight is cut from each of the alloys, right? So let that piece's weight be x kgs, right? So we have 8 minus x kgs of alloy, right, with A% aluminium. So the total aluminium in this piece would be 8 minus x into A by 100. Now similarly, the total quantity of aluminium in this piece would be x into A by 100. Now similarly, from this 16 kgs piece, again x kgs is being cut. So the amount of aluminium would be x into B by 100, and you're left with 16 minus x kgs of piece, in which the amount of aluminium would be B%, B by 100. Now the first piece is alloyed with the second alloy and the second piece is alloyed with the first alloy. So these two are mixed and these two are mixed. Then what happened? As a result, the percentages of aluminium become the same in the resulting two new alloys. So it's not the amount of aluminium, it is a percentage of aluminium, right? So if I mix these two, what is the total amount of aluminium? That would be 8 minus x into A by 100 plus x into B by 100, right? Now this is amount of aluminium, right? Now what would be the percentage? Now when you add these two, what is the total amount that you are getting? 8 kgs, because x kgs is being removed and x kgs is being added, so there will not be any change in the weight, right? So percentage of aluminium would be by 8 and into 100. Now this should be same as percentage of aluminium in the second piece. That would be 16 minus x into B by 100 plus this is being added to this A into x by 100 by what is the weight of aluminium here? 16. Now in percentage into 100. So I can remove 100, 8, 2, 16. I can remove this 100 as well. So we have 2a into 8 minus x plus 2 into b into x is equal to 16 minus x into b plus a into x, right? Now let me just distribute this. So this would be 16a minus 2ax plus 2bx is equal to 16b minus bx plus ax. Now shifting 16b to left hand side, we will be having 16a minus 16b is equal to, right? Now 2ax sent to right hand side plus 2ax plus ax, 3ax minus 2bx when shifted to right hand side, that becomes minus 2bx minus 2bx minus bx minus 3bx, right? Now I can take 16 common. If I take 16 common, you will be having a minus b, and here I can take 3x common, then you will have a minus b. Now let me cancel a minus b on both sides. So what is the value of x? 16 by 3, which is nothing but 5.33 kgs. So the piece that was cut from both the parts should be 5.33 kgs, hence C should be the answer to this question. Now coming to the second question. A new sequence is obtained from the sequence of positive integers 1, 2, 3, so on, and by deleting all perfect squares. So perfect squares are deleted. Then the 2022nd term of the new sequence is, right. So 1, 2, 3, so on. Right. Now if I assume that no number is being deleted, then 2022 should be 2022nd term, but what are deleted? Perfect squares, right? So how many perfect squares are there from 1 to 2022? We have 44 perfect squares, because 45 square is equal to 2025, right? So 44 numbers are deleted, so that's the reason 2022's, sorry, 2022nd term is not 2022, it will be more than 2022, right? Done. So since 44 numbers are repeated, 2022nd term will be 2022 plus 44, right? So because we have removed 44 numbers, so we'll be adding 44 numbers. So 2066. So most of the students answer this question as 2066, but there is a catch here. Why? Because from 2022, next number is 2023, next number is 2024, next number 2025. Right. Now, can we include 2025? Strictly no, because that is perfect square. 45 square is 2025. You should not be considering that. So we won't be considering 2025. So this will shift to next number, because we are again subtracting one term, one number. You should be adding one to that. So 2022 plus 44, 2066 plus 1, 2067 should be the answer to this question. Now coming to the third question. The third, 14th and 69th terms of an arithmetic progression form three distinct and consecutive terms of a geometric progression. If the next term of the geometric progression is nth term of an arithmetic progression, then n equals, right? Now third term, let the starting number be a and common difference be d. So third term will be a plus 2d, right? And 14th term, a plus 13d, and 69th term a plus 68d. Now given that these are three consecutive terms in geometric progression, so a plus 13d whole square, b square is equal to ac, so square is equal to a plus 2d into a plus 68d. Now let me expand this. So this is nothing but a square plus 26ad plus 169d square is equal to a square plus 70d plus 136d square, right? Now I can cancel a square on both sides. Now shifting 26ad to right hand side, 70ad, sorry, so this should be, yeah, 70ad, my bad, 70ad minus 26ad, that should be 44ad is equal to 169d square minus 136d square, 3 and 33, 33 d square, done. Now I can cancel d on both sides. Now 33d is equal to 44a. Now 11 threes, 11 fours, or a by d is equal to 3 by 4, right? Now we have a relation between a and d. A by d is equal to 3 by 4, right? Now let me consider a is equal to 3 and d is equal to 4, right? So instead of 3x and 4x, for the calculations to be easier, right, now I'll be considering a is equal to 3 and d is equal to 4, because we are nowhere asked to find this much like 26 term of arithmetic progression, no, right? Now we are asked to find if the next term of geometric progression is nth term of an arithmetic progression, then n equals what, right? Now if A is equal to 3 and D is equal to 4, now what A plus 2D will be 3 plus 2 into 4, 8. Now this is 11, right? A plus 13D, 40 to 40, sorry, 50 to 52 plus 3, 55. And then A plus 68D, 272, 272 plus 3, 275. Right. Now this is the third term, 14th term, and 69th term. Right. Now what is the common ratio? Now how did we get 55? Into 5. Now this is into 5. So the next term in the geometric progression would be 275 into 5. Now what is 275 into 5? 200 into 5 is what? 1000. 75 into 4 is 300 plus 75. 1375. Right. Now this is with respect to geometric progression. Now we are asked to find 1375 would be what term in the case of arithmetic progression. Now we have a, let that be nth term. So Tn is equal to A plus n minus 1 into D. Now 1375 is equal to, now we have the value of A as 3 plus n minus 1 into 4. Now 1375 minus 3, 1372 by 4 is equal to n minus 1. Now this is 343. Now 343 is n minus 1, or n is equal to 344. Right. So the next term in that geometric progression would be same as 344th term in the given arithmetic progression. So the answer for this question should be 344. Now coming to the next question. Mrs. and Mr. Sharma and Mrs. and Mr. Ahuja along with 4 other persons. So that means there are 8 persons are to be seated at a round table for dinner. If Mrs. and Mr. Sharma are to be seated next to each other and Mrs. and Mr. Ahuja are not to be seated next to each other, then the total number of seating arrangements is. Now we need to have Mrs. A and Mr. A sitting together. So we should be considering them as one unit. And we do not want Mrs. S and Mr. S sitting next to each other. So let us exclude them for now. Right. Now if I exclude Mrs. and Mr. S, now we will be left with 6 people. Now out of this, now these two should be always together. Right. So if I consider these two to be one unit, you have 5 units. So 1, 2, 3, 4 and 5. Now this is nothing but Mrs. A and Mr. A, right? Now we have to place Mrs. and Mr. S so that they won't be sitting adjacent to each other. First, in how many ways can we place these 5 people? 4 factorial, done, into 2 factorial, because 4 factorial is what? 4 factorial is the outer arrangement, into 2 factorial. Now you can shift or you can interchange Mrs. A and Mr. A in 2 ways. So into 2 factorial, done. Now since Mrs. S and Mr. S should not be together, now by placing these 5 people, how many places did we get? 1, you have 2, you have 3, you have 4 and you have 5. Now out of these 5 places you can select any 2 and you can place them. They won't be together, right? So from 5 you need to select 2. So that would be done in 5C2 ways. Now after selection, now once we have selected 2 places, now Mrs. S and Mr. S can be arranged in those 2 places in how many ways? 2 ways, done. So what is 4 factorial? 24 into 2 factorial, 2 into 5C2, 5 into 4 by 2 into 2, done. Right. 24 into 2 is 48, 48 into 2, sorry, 48 into 20, 960 should be the answer to this question. Now coming to the last question. In a right angle triangle ABC, the hypotenuse AC. So right angle is at B. Okay. So this is right angle triangle ABC. Hypotenuse is AC. Now AC is of length 13 centimeters. Right. If this is 13, these two need not be 5 and 12 in that order. No. Right. So this can be 13 by root 2 and this can be 13 by root 2 in case if it's a isosceles triangle. Right. So to use Pythagoras triplets, you should be given with at least 2 sides of a right angle triangle. Right. So with one side, I cannot determine that the other 2 sides will be mandatorily 5 and 12. No. right? Then what? A line drawn connecting the midpoints D and E of sides AB and AC. So this is D, this is E. Now, if I connect the midpoints of these two sides, I know that this is parallel to the third side and also half of it, right? Now, what is the length of DE is given to be 6 centimeters, right? Now, if this is 6 centimeters, BC should be twice of that, 12. Now, what was asked? The length of AB is. Now, if this is 12, this is 13, this should be 5 units. So, the answer for this question should be 5.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.